Hi.
Hello.
Thanks everyone.
Hi. Should we wait a couple more minutes or get started now?
We'll
Yeah,
just
let's
give a
wait.
minute. Yeah, sorry.
There was a meeting just right before, and I guess a couple of more people will join from there.
Yeah. So by the way, we started using some of the Bazel builds system builds, and it is super fast. It's awesome actually.
Sorry, can you please repeat?
Yeah. I think we started some of the the release builds, and some of the builds I tried to make with Bazel, and they were super fast. And I think the installation was also, I think, was smooth because otherwise, you have some dependency issues, this packet missing, that packet missing. So at least whatever we tried, it went through smoothly.
Oh, this is nice to hear. Thank you. So I guess we are now a lot of people. So Lars, feel free to take over and start.
Yes, hi everyone. So let me just screen share. All right. Well, hello everyone. Welcome to the Bazel Magma Show and Tell for the Access Gateway. And a bit of background on myself. So my name is Lars. My background is in theoretical mathematical physics. I studied at Saarland University and the University of Cambridge, then did my PhD here in Berlin with the Max Planck Society before joining TNG. And I've worked on Magma for a bit over a year now. I started at the beginning of last year, mainly working on DevOps tasks and in particular on the Make to Bazel migration for the Access Gateway. And that's sort of the topic of today's session. Just to sort of set the kind of topics we want to talk about. So we already had a lot of engineering meetings where we talked about how developers can use Bazel at Magma. And this will be, to some extent, also a topic today, but I also want to focus on what it would be like to maintain Bazel for Magma, what tasks there are, and some behind the scenes things that maybe developers don't really have contact with, but that people that would maintain the build system would need to know about and might want to optimize in the future. Are there any questions so far?
I
If not,
think all good.
oh yeah, Yogesh?
All good. Yeah, it's pretty clear.
Sorry, I didn't quite get that.
Yeah, it's
Okay, I think I'll just continue then. So I want to start by highlighting some of the benefits that Bazel could have for Magma and for the Access Gateway. So first of all, it's a multi-language system, so it's not specific for one tool or language. It's also multi-platform, and you can also extend it to languages or other tools that aren't supported yet. And it's meant for monorepos like Magma, so this is really exactly the use case that was intended for. You can support multiple architectures, so including ARM, different configurations, things like that. And because it's multilingual, you can also support TypeScript and other languages. In principle, it's possible to extend Bazel to the other components of Magma. This is a non-goal for now, but you can extend it to NMS, for example. That is possible. Bazel is also an open source project with an active community. This is really helpful if there are questions regarding the build system, because it's not Magma specific. Most of the questions you can probably find in any kind of Bazel resource in general. And also if you're working on the build system from a maintainer perspective, if you have very detailed technical questions, or you might want to collect some ideas on how other people are doing CI or DevOps, there are resources on finding things outside of Magma. There's also a clear file and target structure. We get into some more detail on that later. But it seems to be that the community can sort of deal with this. There's already a bunch of PRs. I listed some here, a lot of them from the C++ migration, for example, where community members have modified Bazel files or added tests, things like that, and yeah, running testing for PRs with Bazel. Another thing is that Bazel tries to keep builds reproducible, and some ways of doing that is, for example, hermetic or sandboxed executions of building targets and testing targets, and with strictly defined in and outputs. And what this means is that for example, we'll see that later, if you want to run a unit test, the test won't be executed in the repository, but instead it'll be run in a sandbox, and only things that you defined as inputs would be copied in. And you also can't access like standard in or the system time, things like this. They aren't accessible to your builds. So you're safer from using things that you aren't aware of. Also, some convenient features like build profiling are really good if you want to optimize some performance bottlenecks. So if you click on here, this is going to get you to the Bazel documentation, and there's a performance profiling section here. In particular, like this trace profiling, it basically looks like this. If you open the profiles with Chrome, you can get information on CPU usage, memory usage. You see what processes are running, how are they parallelized, things like this. All of this is sort of free and out of the box. You just need to look at it if it's required. There's also a powerful query language. There's a lot of things that you can do with it. Right now, we're mostly using it in CI to classify or filter lists of targets. So if you have a lot of targets, you could ask, are there any C++ unit tests in this list, things like that. But in principle, you can also use it to make dependency graphs, for example, to analyze the architecture of a service. Then we'll come to sort of the main points, I think, that are really important, is that the target structure and the way that things are defined in Bazel are really granular. And also there's no circular dependencies allowed. And this is something that is really helpful in avoiding regression in the future. Right now, we already have an MME target that is very, very big. because there are circular dependencies, so you can't split it up, and this requires a larger refactoring. But if you always define everything in a granular tree-like dependency graph, then you won't ever have this problem in the future. And you also have some tooling to restrict the visibility of these targets. We'll see in a bit more detail what targets actually are and things like that. But this is really good for keeping services separated and knowing what resources you're actually using. And these granular targets also allow you to only build and test exactly what you need. So as we'll see in CI, you only need to run the unit tests that are actually affected by your changes. You don't need to run everything. And overall, this just makes everything faster. Also, the builds are incremental. So if you build something, if you build a service and then you change some small part of it, you only have to rebuild what has been changed. You don't need to rebuild everything. And this is combined with caching. And this is maybe one of the most important parts here, that you can share your build results with other people, basically. So locally, when you build something, Bazel will start a disk cache. And so it will remember intermediate build results that you have already done at some point. And if you have a remote cache, for example, in CI, this is very useful, then you can share those intermediate results. Overall, this adds to parallelization and scalability. There's also remote execution. We've never used remote execution in Magma, but in principle, you can also have completely distributed builds where you want to build one target, but maybe one runner, one machine builds part of it, and another machine builds a different part, and they can also access the same cache, things like that. Do we have any questions on this part? Otherwise, I have collected just a couple of resources here. Sort of, maybe you're aware there are the Magma Bazel docs in Docusaurus. So there's a larger page here. Right now, it's still in the getting started section on the docs on master. And we'll cover a bit of what is contained in here, but there's a lot more details and it's more developer focused. So there are some basics on what structures are there, what files, also caching. And then there are more detailed sections on building targets, on testing things, running services, things like this. There's also a small section on querying, on Bazel CI, on the release build, on debugging, and debugging also contains some of the profiling and tracing information. Then there is, of course, the official Bazel docs. There is a lot of information in here. Some of it is rather technical, but really most of the very general information you can find here. There's lots of resources. It's not always the easiest to find the right page, but when you have it, it really contains a lot of information generally. Then there's the Magma Slack channel, #Bazel. Of course, this depends on there being people that drive the topic and can answer things in the channel. But it's also a good resource. And then there's the official Bazel Slack with lots and lots of different channels. There are thousands of users for lots of different topics, but it's really, really helpful, and you can get help really fast there, and people are very friendly. It's a very active community. There's also lots of conferences, so this is also a great resource to have. So then first, I want to talk a bit about caching with Bazel, in particular from a DevOps perspective. So as I said, locally, there is a disk cache that Bazel will create when you run any kind of build or test. But in CI, you need to share the cache, because otherwise you don't really have an advantage. If you always start from 0, then only subsequent builds will be faster. But if you have a cache that you already have at the beginning, then everything will be faster. And so the best way of doing that is remote caching. This is a built-in mechanism that is completely different from the disk cache, but they can cooperate. And remote caching really is the recommended method because it can scale arbitrarily, basically. It's very convenient, very robust. You should just make sure that the remote cache is running on a server that has a high availability and a good connection to where your actual runners are. So in the case of GitHub, of course, like Azure would be really good, but actually there are easier ways of doing that. So the very simplest setup is with Google Cloud. This is of course because Bazel has a closer relation to Google, I suppose. And with Google Cloud, you really just need a simple storage bucket, and you can just specify it as a remote cache and set some credentials. So in terms of the infrastructure that you have to maintain, this would be by far the easiest setup. But there's also a Bazel remote, which is a open source repository that defines a remote cache backend server as a Docker container that we used to have last year, that we were running with Terraform on AWS. And there are documentation on how to redeploy this. This is mostly a budget limitation that we don't have it anymore. But if it's possible in the future, so this is sort of directed towards future maintainers, if possible, it would be simplest to go back to remote caching. As of this year, we don't have an active remote cache anymore. What we're doing is a bit more cumbersome, but also works and doesn't produce any cost. It's stable enough for the current setup. So we have two things that we're doing at the moment. One is a Docker cache, as I would say. So there's also, in general, there's also documentation on these caching approaches on the Docusaurus. So in the caching section, there's information on the Docker cache and on general caching, and also on remote caching. So what is the Docker cache? So the Docker cache are basically Docker images that contain cache entries. We publish them weekly in the GitHub container registry. We publish them in 3 flavors. One is sort of plain dev version. There's a production config version and an address sanitizer version. And yeah, because they are published weekly, the cache isn't updated in between. So this is of course a drawback. With a remote cache, you always download exactly what you need and you upload everything that you built that is new. So it's always up to date. This isn't the case with the Docker caches. They sort of go out of date a bit, and then you build a new one, and then it's up to date again, but you need to download the entire cache every time. This is why we split it up, so you don't have to download everything if you're only interested in this part of the cache. Yes. Then there's also a GitHub cache, but this is basically just any other place to store cache entries. So it's both of these approaches here use local caches essentially. You just copy them to different places. Either it's in a Docker container or it's somewhere else. And one thing that we're also using is the GitHub cache. This is size limited to 10 gigabytes, so it's somewhat restrictive, and we also use it for other things. But for caching inside of virtual machines, this is currently the best approach, because the Docker cache really only makes sense if you're doing something in a Docker container anyway. So right now we also have this GitHub cache, and you can manually copy your cache, like your cache entries there, but you need to sort of take care in CI. Sort of as a DevOps maintainer, you need to make sure that the workflow always keeps the cache up to date, that you don't go over the maximum size and so on. So there is some maintenance there, and you need to, it's just less robust than having a remote cache that automatically is up to date and so on. It's just much more convenient. Okay, any questions on the caching topics? All right. Then I want to talk a little bit about runtime comparisons, just to give some ideas of what the Access Gateway sort of, or what Bazel has already improved for the Access Gateway. And these aren't like exact numbers, so don't quote me on this, but they're taking from something like 30 workflow runs. So it should sort of give a feeling for the order of magnitude. So first, so here I always compare the make with Bazel tooling on different things. There aren't always equivalents, but so right now the Bazel workflow running on PRs. What is this doing? So this is doing all the access gateway unit tests and the Debian package builds. There are some other things happening in these workflows, but mainly those are the two important things. And so if you don't have a lot of C changes, generally the workflow on PRs is currently like 1 to 3 minutes. So it's extremely fast for what it's covering. And that is because we have a lot of optimization. I'll talk about that a bit later. If you have a lot of C++ changes, it could go up to 5 to 26 minutes, depending on the situation. So it's a bit dependent on what you're actually doing in the PR. We can also look at just the unit tests. So if we actually force the workflow to run all unit tests, and this is the case if we're not on PRs. So for every push to master, we do run all tests. There's still a lot of caching, of course, but we do run all of them. And this will take about 8 to 10 minutes. If the cache is very outdated, because there have been a lot of C++ changes in this week before the cache, so the Docker cache has been rebuilt, this could go up to 20 to 35 minutes. Of course, with a remote cache, this wouldn't happen. We would just always stay at the optimum time, sort of. So comparing this to the make workflows, this workflow doesn't exist anymore, the make one. But I went back to the logs and had a look, and it was a bit parallelized. So MME and Python tests, they were running in parallel. But the longest session by far was MME unit tests. And they always took 40 to 50 minutes, so much, much longer. But of course, they didn't have any real caching or something like that. And yeah, so there's already a pretty big difference there. And then we can also look at the coverage for C++. And with make, this is almost an hour. With Bazel, this is running now in the access gateway coverage workflow, and it takes about a quarter of an hour to half an hour roughly. And yeah, perhaps the biggest difference is in the Debian package builds. With make, this is still happening in CI. In the build all workflow, the AGW build job, and it takes well over an hour. 1.5 hours or more. And with Bazel, we actually do this on every PR as well. Sort of, it's duplicated, and it takes 7 to 14 minutes. So it's very, very fast. And yeah, we publish the images only when you merge it to master, of course. Okay. Any questions on these runtimes? It's probably a lot of information and it's very fast, but there are a lot of topics to cover in this sort of community handover format. So I hope you can follow. And I actually want to sort of stay with the CI topic for a little bit. We already had the show and tell that was more concerned with CI topics. But I want to go in a bit more detail on some aspects of CI workflows. So first of all, I prepared, there is also a section in the Docusaurus on the CI workflows that are most relevant. I already mentioned the coverage workflow, Bazel workflow. Yeah, there's the workflow that also built the Docker caches. There are the intake tests for Bazel. So the Python tests. Yeah, so you can find some more information here. And I prepared a demo PR. It's this one. It's not very interesting. Basically what I did here, there's some Python file in mobilityd. I just added an import here. It's not really important what it is. And then there is one unit test that I changed, where I added an assert that is guaranteed to fail. So then if we're going back and looking at the checks on this PR, we can see here the AGW build, format, and test Bazel workflow. So we can just click on that. And yeah, we can look at the summary first. So this is sort of the rough outline. The main jobs here is this one, for example. This is running all of the unit tests in the 3 different configurations. Here we're running all of the tests that are necessary. So this is failing because of the change that I did to make it fail, just so we can see that. And then here we have 2 different configs, so production with a leak sanitizer and address sanitizer for the C++ tests to check if there are any memory leaks or address sanitizer issues. And this is running in a matrix workflow. And because this job is required, there's some additional setup needed here. I don't want to go into too much detail. This is also documented in PRs and issues. And then the overall status is reported here for this job. Then the other important job here is the package job. This is what builds the Debian packages. And if this was a merge to master, we would also release the services to Sentry, but this is not so important right now. There's a smaller check here that looks at if any Python services have been affected and checks the imports, because Python is a bit special. You can have failures during a runtime that you wouldn't see when you just build them. So this job starts the Python services and checks that there are no module not found errors. Yeah, there are some other smaller checks, but I won't go into detail on these. What is important here, especially for maintainers, would be the Bazel diff job. And this is sort of the brain of this workflow. This controls if the other jobs should run or not on PRs. There's a general path filter in front of it, but this is just very crude. So let's look into this Bazel diff job here. Also, you can, in the documentation, there's also a Bazel diff section. So you can also read up on this here again. Bazel diff is a tooling from Tinder. It's an open source tool that helps you to figure out what you actually need to do, because it can tell you if you have the changes from a PR, what targets are actually affected. So does this test need to run, and so on. So in this job, we run this tool here, and then the important step is where the outputs are set, basically. And so just to quickly summarize, sort of, okay, the first variable here tells you that this tooling ran on master merges. This wouldn't be true. And then because I affected this Python service target, it also tells you that the package job should run because there was a service affected. And because the service was affected, a bunch of Python tests need to run. Yeah, there's also this one individual test that I modified. There's no C++ tests that need to run, so we can skip all of that. And there's one Python service that I affected. So this then controls all the other jobs. And now if we look into the failing job, this will jump right to the end. You can see exactly which tests ran. So you can see the one test that I manually modified was a PolicyDB test, and it failed because I made it fail. But this is where you would find out about it. And there's a summary here also that it executed 10 tests, 9 passed and 1 failed. There are some runtime summaries. You can see how many cache hits did you have. It says disk cache now because this is the Docker cache. And yeah, so this is what you would see. And if you want to know why it failed, you can scroll up a bit. Here you have the logging and output from the test. And you can see that there's an assertion error here that false is not true. Yeah, so this is sort of what I wanted to show here, just so you have some idea of what this job does and how you could check why it failed. Yes, any questions on that? All right. Then I just want to talk a tiny little bit about what files are there and what do they mean. So, and as a primer for that, all of the Bazel files are basically written in the Scala configuration language. It's a deterministic language. It's hermetic and parallelized, so it mirrors the general attributes of Bazel, and it's a Python dialect, so it should be sort of readable if you have some Python experience. hermetic and so on. This means that, again, the language can't access the system time and things like that. There is a page also in the docs on what the file structure looks like. So you can read up on all the details here again, but basically there are like 3 basic kinds of files. One is the workspace file, and this is what defines a Bazel project. So for Magma, we only have one, and this is the base of the project. Then there are Bazel RC files. We only really have one. There are some more specialized Bazel RC files in this Bazel RCs folder, but mainly the configuration of Bazel is handled in this file. This is where we define what config production means and things like that. And yeah, the workspace file, it not just defines the project, but here you also import the tooling, sort of what languages do you want to use, things like that. And then mainly what you have most is these build files, and they define a package. So lots of folders here have build files, like mobility D, there's a build file, the test subfolder, there's a build file. They should be pretty much in every folder where you have files that you want to use, because that gives you the granular structure. So the mobility D would be one package, the tests would be a package, and so on. And these build files then contain targets, which we'll come to in a minute. And otherwise, there are some more specialized folders here, as I said, for more specialized configuration, for external dependencies. There's a requirements in file here for pip dependencies, for example, for Python. There's a script folder where the Bazel diff tool, for example, is configured as a shell script or a formatter for Starlog. Okay, so just as a general idea here. And then, well, what is a target? Just basically, it's a configuration of a unit of code that you want to structure. So in these build files, you have these targets. There are different kinds of targets. This would be like a code library for C or C++ code. It has a name. It has some sources. Because it's C++, it can also have a header, and it would have some dependencies. And then these targets can depend on other targets throughout the code or in external dependencies. And this is like the basic structure. There's lots of different kinds. There's like libraries, binaries, tests for different languages, and there's other kinds of targets. Okay, that's just as a very general primer. Any questions on that before we continue? Otherwise, I also want to recommend the Bazel help function. You can just type Bazel help. They'll just give you the basic Bazel commands that you can also find in the docs or in the official command reference, which also has a very detailed list of all the possible Bazel commands that then have subcommands and options and things like that. The basic ones, of course, are like build and test and maybe run, query, things like that. But yeah, with Bazel help, you can just like type Bazel help and then the things that you're interested in, and it's going to list lots and lots of options. But otherwise, you can also check out the official documentation or the Magma specific documentation. So I want to keep this section quite brief, but just a couple of points. First of all, how do you build anything, and where can you find the artifacts? So let me quickly switch to the dev container. Okay, so let's say you want to build a service like SMSD, then you would basically just run a Bazel build. So this is one of the commands for Bazel. And in this case, we can just specify the root of the project with 2 slashes and then address the target SMSD. This is a convenience function that we added. So all the service targets are defined at the root of the repository. Otherwise, you would have to specify the path to the target. So for SMSD, it's like LTE gateway Python Magma SMSD. And then in this build file, you have SMSD. And this is sort of what it also reports down here. So you could also have built the target by specifying the full path here and then specifying the target here. Okay, so now it's built. It was very quick. It's a small Python service, and also it was completely cached. You can ignore the internal one here. It's all already in the disk cache. And now You can do an LL on this path that is reported here, and you see that the executable is here. And yeah, you can poke around in this folder. It's the Bazel bin folder. You can actually also click on this, but I don't want to go into details here. So there's a Bazel binaries folder where you can find all the build outputs, the run files, all of that. And yeah, that's where you can find all of that information. Then next, I want to talk a little bit about the Debian package build, just because it's a bit special. Because you might want to just Bazel build a target that then builds a Debian package. But the important thing is that this package has some version set that contains information like a timestamp and a commit SHA. And these, of course, change. So it wouldn't be deterministic, or it wouldn't be reproducible to have varying timestamps, for example. That's not possible. So we have to use a kind of workaround to do that. So let's go to this build file. Actually, I already have it open here. So it's LTE gateway release and then the build Bazel file there. If you scroll all the way to the end, there is a big target here, which is an SH binary. That means a shell binary, so a shell script, basically. If you build this target, it's going to build a shell script. And if you run this target, so here in the comment, you already see a command. If you run this target, it will build a shell script and then run the shell script. And this shell script will lead to a version being set that looks like this. So this is sort of a workaround. The important part here is really the data. And you can see that there are 3 different kinds of Debian packages that are included here. And we can control click on these links here. Let's say the Magma Debian package will jump to a different target further up here in this file. And this is the actual package. So you can build that, but it won't have the right version set. And so you see there's lots of things here like architecture or maintainers or license file, things like that. But again, the interesting part is the data, the Magma content. And we can again control click on that. You can see there's a package tar here, which is again a different kind of target now, with lots of contents, and you can already see kind of the structure of this Debian package. For example, there's a license file, there are C binaries, Go binaries, Python services, things like that. So we can follow, for example, the C binaries. This is still in the same file. It's a package. Files is just grouping of services now. And for example, we see here MME or session-D as targets, and we can follow these. So we can go to session-D, and now we're jumping to a different build file. Maybe you noticed we're now in session-D folder, and there is a big CC binary target here, which as a source has the session-D service. And you can see the dependencies, and you can just continue jumping to the lowest possible level. Basically, you can jump to this library here. It's in the same file. So this is Magma dependency. There are some sources here, CPP file, header. And this library again has dependencies. And for example, in this case, it also has an external dependency on this enrollment JSON package. Okay, so just as a rough overview of what the structure would be and how this release is built on a very large scale. All right, next, and I want to keep this point very brief. So of how do you run tests? You can check out the documentation here. It lists these different groups. Basically, the only tests that we're really running completely sandboxed with Bazel are the unit tests. And that's completely possible and easy. The other things like integration tests, and pseudo tests and load tests, they're a bit more tricky because they generally need some kind of system access that is against the spirit of what Bazel tries to do. For integration tests, you need something like access to network configuration and things like that. So this is something that you can't really do when you're sandboxed. And so there are other ways of doing it with scripts and so on, but it's all documented here. So I won't go into any of these details. In particular, for the LTE integration tests, there's a completely different documentation page, which is the S1AP integration tests, and there's lots of details here on how you run it. And yeah, you can check that out. Okay, any questions on this part? Otherwise, I would continue with a little live coding session. All right, so what I want to do here is, let's say you want to add some new unit test. This is the example that I'm going with, but it could also be a library or a complete module or a service or something like that. And so how do you write a build file and how to add some dependencies, things like that. Yeah, again, there's some useful links here, like on the Bazel documentation, what is a build file? It's going to tell you lots of useful stuff. Also what the different kinds of targets are, but let's get to the practical part. So I prepared a unit test here. We're in the SMSD service, and this is what is currently on master. So there's a main file for the service, and there's this relay file. That's it. There's no tests. We don't have tests for SMSD, at least no unit tests. So what I did is I just created a test folder with an init.py and this test file. The test is very stupid. It doesn't do anything useful, but it's just for the demo. So what I do, well, there's a copyright header, we import unit test, and we import a pip dependency just to showcase how that works. And then we also import a Magma dependency, which is this relay file here. And we just import some constants. What the test is then doing is it just asserts on these contents, on these constants in the first 3 cases. And then just to use the pip dependency, we use parameterized to add these different sets of numbers and check that they agree with the 3rd row here. Okay, so this is what the test is doing. It's not interesting. It's just so we have a test that is using a pip dependency and a Magma dependency. Okay, so now we added this test here. And the question is, how do we actually connect that to the Bazel build system? And so the first step is to add a build file. And so we already have a build file in this SMSD folder. And as of now, this test would be part of this package, sort of. But we want to have a granular structure that is fine-grained. So we'll create a new build file in this folder, which will then be its own package. Let's just create this file. And so just having this file is enough to have a package here. Now, because we're creating a new file, I'll just quickly copy a license header. Oh, got lost here. So, and then now it depends sort of what you want to do. Here we want to have a test. So we need to first figure out what is the right vehicle for this test. And in the case of a Python test, I would just add this load statement here. Load, you can sort of think of it as an import from function in the sense of Python. So we're loading the definition of this PyTest, or what it means to be a PyTest from this tooling here. And with that, we can then define a PyTest. So for now, it's just this function. And now we give it some parameters. What are those parameters? Well, first of all, we give it a name, and that we just set as an attribute. The name is just a string, so it's good to just keep that in sync with the file names. So we call it test demo or this test suite. So just call the target here also test demo. And then of course we need to add some sources. So that's generally just srcs. And the sources, there could be many sources, so it's a list. So let me just add a list. And in this case, the source is just this Python file. So it's just test demo. I already get suggestions here. Okay, so you could think this is it, and yeah, we can just try to run that just to see what happens. Usually if the plugin installed, you can just right click and then copy label to clipboard. Then you can just type Bazel test because you want to, you could try to build it, but for now I'll just try to test it. and just paste the label here. So then we don't have to type all of this. So this is just a folder structure from the location of the workspace file, all the folders up to the test folder, and then the colon denotes the name. And then the name is test demo because that's the name that I've chosen here. So let's just try to run that. And that fails. And let's see. So the important line is here now. It's missing one required positional argument, size. And this is a thing that all the tests have. So let's just add that. So there's a size argument, which is just a string. And basically there are only 3 sizes. It's like small, medium, and large, I think. And that just determines how many resources this test has. It determines timeout, CPU, and memory consumption. But for Python tests, usually it should just be small. So we just try with small, and if it fails, we can still make it larger. This is also useful, like if there's a lot of regression in the runtime of a test, for example, you would see that at some point Bazel would complain that this size limit was too small. Okay, so then let's try again. Okay, so now the build actually worked. We can see here in the logging, it says build completed, but the test failed. So why did the test fail? Well, we can scroll up a little bit again, and here we see the logging. We see here that there's an error, module not found. So this is detected at runtime because it's Python, and it doesn't know the module parameterized. And that is, of course, because the test is using parameterized as an import here. So we need to tell it that it should copy this package, this dependency, into the sandbox, or let us access it. So we add a depth attribute. Again, dependencies are a list. There could be many here. So let's add a list here. And now, as I said, parameterized is a bit special because it's a pip dependency. So we need to use something called requirement, or requirement, and you just type in the string of the package. I can also copy it from here. Parameterized. Okay, and now in principle, this should work, but it doesn't work because requirement is not defined. Now you notice that the IDE is already highlighting requirement here in yellow, like PyTest. So what we're missing here is another load statement because we need to load the definition of what a requirement is. Okay, and this only works, by the way, because parameterize is a package that we're already using. So if you look at the requirements file, which is in Bazel external, you can see that there's already a parameterized here. Otherwise, you would need to add it and compile the requirements txt. But this is already done. It's already a known dependency. So we can just continue. Okay, so now that is gone, but now it's complaining about Magma. It doesn't know Magma because of this import here. Okay, and we want to import this package from Magma. Why doesn't it find it? Well, it's because the test is running in a sandbox. There is no Magma so far. So what we need to do, and this is only true for binary or for executable targets, let's say, so tests and binaries. So we need to add an imports statement, which modifies the Python path. These imports, again, there could be many, so it's a list. And to define this import, we need to define where Magma is as a package. So first, I will add the Magma root, and this is just by going back to the Magma folder. So you go back 6 times here. That's why you go back 6 times here. And then from there, I will just define where the Python LTE root is by using this. This is just more convenient to have the same definition in every file. So you vary where the Magma root is, and then you just insert that here and go back to LTE gateway Python, which is the base of the Python package here. And so we can add this to the Python path as an import, and then we can find the Magma package. So let's try again. Okay, So that works. Now it's complaining that it doesn't know what relay is. So it finds Magma, but it doesn't know about relay. And that's because we import relay here. So this is now a real import of a package. So it's a dependency. So let's just add that here. Okay, so this would be a string, and then you basically just start from where the package is. Sorry, so it would be like LTE gateway Python Magma SMSD, and then you need to actually check where it is. So okay, I already know where it is, but or I guess if you wrote a test, you will also know where it is. So relay is here. There is a build file in this folder, so I just go there, and then I can check what targets are there, or you just search for the file actually, and you see relay is its own Python library. So I can just use that. Or actually, yeah, you can just, again, right click and copy to clipboard to copy the label of that target. So let's just paste it here. And now we told this test that it's allowed to use this package. Okay. So let's run that. Okay, now it's saying here that the test is actually importing relay, but relay is importing something from Magma Common job. But it doesn't know where Magma Common is, and that is because there's a different part of the repository. We only imported the LTE route, but there is also an orchestrator route. So let's also import that. Oh yeah, and so it's highlighting it yellow now because we haven't used it. So let's just add that here and add some formatting. Okay, so now it should be able to find this transitive dependency. The relay target doesn't have the orchestrator route because relay is a library. There's no imports here, and there shouldn't be any. These imports need to happen at the dynamic targets. So in this case, the test. Okay, so we import that. The Python path should now allow us to find everything, and the test is green. So build is completed and the test is passed in 0.6 seconds. Now we can run the test again, and now it says cached. That is because we haven't changed anything. It's just caching the test now because nothing has changed, so it doesn't actually need to run it. It just tells us the same logging again and says, yeah, everything is the same. I don't need to run this test. You're good. Okay. Any questions on what we've done here in this live coding session now? And so for, yeah, if you were to just add a library, it would be very, very similar. You would just import the definition of a library, then define the library with the attributes that you need, and then use it as a dependency wherever it's needed. And yeah, for a service, it's basically the same. It would be a binary target. You create new folders, new build files, and add the dependencies that you need. And yeah, for the dependencies, also in the Magma docs, there is a section that talks exactly about that. So you go to building dependencies, there's a section on local dependencies, external dependencies, and then specifically for Python, also the pip dependencies. All right, then some updates, or yeah, let's just talk in general about the current state of the migration of the Access Gateway. So less technical. Basically anything that could be done with Make can now be done with Bazel. There are some exceptions, like formatters, but those are things that aren't really done with Make. Their Make is just used to execute another tooling. So yeah, you can either just keep it with Make or define aliases for this tooling or use Bash scripts or Python scripts. There's lots of options, but they're sort of detailed and there's not too many targets that are concerned with that. All the important things like building, testing, all of this has been migrated. Regarding CI, there are a bunch of workflows that are completely migrated already. This is like the Access Gateway unit test, like I said, and the coverage generation for C++, C, and Python. And yeah, then the package build is also duplicated. So as we saw in the Bazel workflow, we're building the Debian package with version 1.9, and Make is building the package in the build all workflow with version 1.8. And these artifacts are then tested in duplicated LTE integrest workflows. What is still missing CI-wise and what is in progress or review are the FEG integration tests. They also use the access gateway and is currently still built with Make. There's no reason for that. We have a PR to change this, actually completely refactor this workflow to use a Debian package installation instead of a build from scratch, which is sort of closer to a production environment. And yeah, there's a PR from Niels in review to do that. Now, for the tasks that need to be taken over for the community handover, in general, there's a list of open Bazel issues. There's a number of issues open now. Generally, they all use the Bazel tag, but most of these issues aren't really needed for a switchover. There's a lot of technical debt, nice to have. Yeah, just all kinds of issues that are in the Bazel context, so to say, or just optimization as well, analysis tasks, things like that. There are a couple of tickets that should be done after a switchover has happened, so when Make is completely switched off. And they are tracked here. There are some refactorings, some if-def statements that are needed, things like that, some cleanup. But yeah, so that is it. So the switchover could go ahead in principle from the technical side as soon as the FEG integration tests are switched over. And in terms of long-term maintenance, so mainly there's like the general build system maintenance and optimization that would need to be a community-driven effort then. There are things like upgrading Bazel versions. So Bazel has a rolling release cycle. There's all the time there's new versions. And of course, you shouldn't use completely outdated and unsupported versions. So there's some effort to keep this up to date, to see that nothing breaks. And there are tasks for that. And of course, if there, in the future, depending on how the project develops, if more components would be added to Bazel, or if the budget changes, things like this, you could again optimize caching, use remote caches. There's many options, and depending on where the community wants to go. And yeah, with that, we don't have too much time left. I would open the discussion then for the community. And yeah, otherwise we can also talk about any other questions that you might have.
Maybe quickly from my side, but from someone who is into this topic and worked a lot on that. Thank you, Lars, for this very detailed summary. But I'm interested from the rest of the audience. How do you feel? Do you feel informed about the topic? Do you think that there are parts where we should put more effort on? For example, provide another show and tell session to go into even more detail.
Yeah, we could also offer some more hands-on sessions where you could like Bazelify something or add something or make some changes to the build system, or try to specify various targets and use different options. Yeah, if this is something that the community is interested in, we could certainly arrange that.
Thanks for this overview, Lars. I wonder, has anybody reached out about taking over Bazel, in the new community-run version? Does it appear there are new owners?
Yeah. So as far as I know,
okay.
Yeah, Niels.
Yeah, but I guess we both wanted to say the same. So for now, no, nobody reached out directly to take over the topic. The hope is that we find, for example, someone here, but feel free to contact us after the session as well, if you are interested and want to have more insight.
I think we should talk about this. Maybe being more proactive to make sure there's somebody there to take the baton, which you guys are holding out.
Yeah, of course. But maybe one additional point from my side for that. I mean, it would be the same for Make. So I don't think we have one responsible contact person for the Make build system. So if there's nothing, no one to be found to feel take over, at least for some time, to be a single point of contact for the Bazel topic, it's not a huge problem, because again, we would have the same for other build systems for Make.
That makes sense. Mickey or Sikander or Tapas, do you have, I don't know, how does it feel like from the Wave Labs point of view? Do you guys feel like you have a mandate to start owning this stuff?
From my end, I have to look at it more, because Bazel is new to me.
Yeah.
If I remember correctly, Jordan, I think you unmuted.
Yes, I was waiting for everybody to finish. So,
Yeah.
I mean, thank you very much for this presentation. At least, I mean, for me, it was quite good. We had quite a good hands-on demo, so people can now understand how to add new targets and how to maintain this. Because the way that you are adding is the same way that you can maintain them, and adding new files in the existing targets, or adding new dependencies or removing dependencies from the existing targets. I mean, we can ask the community if they want to see additional things for the future show and tell on the same subject. I might also come up with some questions of my own. And related to the who takes over Bazel, I mean, in my view, if nobody explicitly will take it, it will be taken by whoever adds new features and new files, because otherwise his features will not be built into the artifacts. And whoever takes over and maintains the CI/CD pipeline, because without Bazel in future CI/CD pipeline will not work. And I agree that, I mean, it's the same thing with if we don't move to Bazel, if we still stay with Make, but that decision is done. We are not staying with Make, we are moving with Bazel. I would say that Bazel is much cleaner because it's much easier to understand what's going on. So it will be much easier to maintain and to extend in future. So yeah, this is from my side.
Yeah, thank you. We are already over time, but maybe it's okay if I ask a last question. The next show and tell topic. Would the people here be interested to hear something about the release process? I know that a couple of people here were already involved in the last release, but there were a couple of changes. Some changes are, of course, Bazel related, but in my opinion, the larger changes are related to the new Artifactory that we are using, because in the last release, we had a lot of manual steps on the old Artifactory that are not possible anymore. So there will be some overheads for the next release, and if the community is interested, I could make the next session about that and share what I have in mind about that.
mean, from my side, definitely we should have a show and tell on this. I don't know the opinion of the rest of the people.
Nils, I think it's a very good topic. It will be a very good topic for the next release cycle that you can go to do the show and tell. It's because this is a very important thing, right? The release process itself, right? There are a lot of things that whatever you guys are doing manually, right? So many dots are not even documented, right? So if that is all going to be given as a show and tell, that would be really good.
Okay, sounds good. Then I already have a little feedback, but of course I will ask the question again in the general and dev channel and see if there's sufficient interest. But then we can schedule the session hopefully for next week, next time.
Yeah, and before closing, quickly, I have a question for everybody here. How is the feeling if we are going to speed up the transition from Bazel to Make to Bazel instead of waiting to the to transition on the release 1.9 where we will completely remove Make? How is the feeling if we speed it up and do it faster?
I see the wisdom of that. Like now is when we have the resources. But there's also risk in that. What would we break?
I mean, let's think about this, and we don't need answer right now, but let's have a discussion. Maybe whoever has opinion on this or discussion, let's bring it on the next TSC and discuss a little bit on this, or even before we can discuss in the TSC channel about this speeding up. And yes, Lucas, the concern is about having resources right now, because earlier we do it, we have more resources to support. If we move it later, we will have less resources to support. But if we speed it up, we have tendency to break something. And if we slow it down, we will have less resources to support.
Yeah, I stayed silent because you know my opinion about that. And yeah, I agree completely with the point. Now we could support with the transition. But as you know, a lot of us will not be here much longer. But again, it is prepared a lot. Lars created a very nice draft pull request for the final steps of the switch over. But of course, there can always something happen. But now we are here and could react fast and support with further steps. Okay, now we are way over time. So thanks again, Lars, for the nice show and tell session. Thanks everybody for listening. Have a nice day. Have a nice evening. See you hopefully the next time. Bye-bye.
Thanks,
Thanks,
everyone.
guys. Bye.
Bye.